Within the permafrost in Arctic regions of the Earth, large amounts of methane are trapped within the ice as methane hydrate. CH4X-H2O methane makes up about 13.4% of the mass of methane hydrate. Scientists are concerned that global warming will melt the permafrost, releasing large quantities of methane into the atmosphere. Part A. The HOH bond angle in ice is about 109 degrees, but about 105 in gaseous H2O. Explain why there's a difference. The first thing we need to understand about this question is what a bond angle of 109 and 105 degrees means. 109 degrees, well, that's a tetrahedral shape, and that's a specific name of a shape of molecule that you'll need to learn. And it means that it has 4 bond pairs. 105, well, that's a non-linear shape of the molecule, and it has 2 bond pairs and 2 lone pairs. The first thing we need to write in our 3 marker is that ice forms more hydrogen bonds than water or gaseous H2O. And that's talking about its properties, and hydrogen bonding is a type of intermolecular force. Secondly, we need to write that water has 2 bond pairs and 2 lone pairs. Now we're talking about the shape of the molecule and linking to the question. And finally, we need to explain why there's a difference. Lone pairs repel more than bonded pairs. This is a statement that you'll need to learn whenever talking about shapes of molecules, because it's a set statement that I'd recommend writing in anything where you're asked to describe a shape of a molecule. So, again, to get these 3 marks, we get 1 mark for writing that ice can form more hydrogen bonds, a 2nd mark for saying that water has 2 bonded pairs and 2 lone pairs, and our 3rd mark for linking together and saying that lone pairs repel more than bonded pairs. B. Why are scientists concerned about the release of methane into the atmosphere? Well, methane is a greenhouse gas and therefore contributes to global warming. So that is our set statement that we're going to write to get our mark for this question. So writing contributes to global warming, we'll get our mark. C. Determine the formula of methane hydrate, CH4X-H2O. In the formula, show the value of X to 2 decimal places. Above, I've copied the beginning of the question because it has a key piece of information that we need to use in part C. And that information is that methane makes up about 13.4% of the mass of methane hydrate. So this question is asking about percentage composition by mass. And to do that, we need to take the percentage and divide by the RFM of methane because it's the percentage of methane. The RFM, or relative formula mass of methane, is 16 because it's 12 plus 4, 12 from the carbon, 4 from the hydrogen, and then it's equivalent to 100%, or 16 plus 18x, 18 coming from the RFM, or relative formula mass of water. If we rearrange this, we get 13.4 multiplied by 16 plus 18x equals 100 multiplied by 16. Expanding the brackets, we get 214.4 plus 241.2x equals 1600. Then, continuing to rearrange again, 241.2x equals 1385.6, and that makes our x 5.74. So, when writing the formula, we need to have CH4 dot 5.74 because 2 decimal places, H2O. For this question, you get a mark for the correct formula, and you get a mark for your first expression using the percentage composition of methane and making it equivalent to 100%. D. Calculate the volume of methane in decimeters cubed that would be released from the melting of each 1 kilogram of methane hydrate at 101 kilopascals and 0 degrees Celsius. Give your answer to 3 significant figures. This question is asking us to use the ideal gas equation, which is PV equals nRT. If I write the units for this equation, temperature, or T, is in Kelvin, which is the degrees Celsius plus 273. R is the ideal gas constant, which is 8.314. You get given this on your data sheet in the exam. N is number of moles. V is volume measured in meters cubed. And P signifies pressure measured in pascals. Firstly, with this question, we need to work out the number of moles of methane hydrate. We do this by taking our mass of 1 kilogram, turning the kilogram into grams by multiplying by 1,000, and dividing by the RFM of methane hydrate. So 12 plus 4 plus 5.74 times 18, 18 being the relative formula mass of water. This gives us the number of moles at 8.38 moles. Then we need to rearrange our ideal gas equation to get volume. So rearranging, we get nRT divided by P. If we plug in our numbers, 8.38 multiplied by 8.314 times 273, because our degrees Celsius is 0, divided by 101 kilopascals, we want it in pascals, so we times by 1,000. And that gives us the volume in meters cubed at 0.188 meters cubed. But we want it in decimeters cubed, so converting this, we get 188 decimeters cubed. And that is our answer for part D. For the marks for this question, you get a mark for working out the number of moles, a mark for rearranging the ideal gas equation, and a mark for plugging in your numbers. The final mark is for converting meters cubed into decimeters cubed. E. Suggest why some industries are interested in the presence of methane hydrate in regions of the Earth. Well, the answer for this question is for fuel, because methane hydrate is a powerful fuel source. The mark scheme would also accept energy. So to get the mark for this question, we just need to write for fuel or energy. Both are acceptable for this question.